All right, everybody, welcome to our third section for CS164. Today we'll be covering the basics of XCode and Interface Builder, and we'll be walking through building your first actual iOS applications. So here's our agenda for today. Just a quick review of ObjectiveC's syntax, because it's crazy. Then we'll walk through XCode and its debugging tools, and then go over how to actually start building your app by adding UI components and making them interact with the code that you write. And so we'll end building our own app, tic-tac-toe. So just a quick review of how ObjectiveC's OOP works, because this is pretty different syntax than we've seen for a lot of other languages. So inside of your .h files, which if you use C or C++ is traditionally your header files, and this is where you're going to declare the things that your class will do. So the properties it will have, the methods that it will be able to be implemented later. And the keyword interface is actually not the same as the Java or PHP keyword interface. Kind of unfortunate that they're using the same word, but this is basically just the declaration of everything your class was going to do. The implementation of all of those things you've declared in the .h files is nicely under the @implementation keyword. So here is where you actually provide the code that will define all of your class methods, and here you'll also synthesize your properties. So if in a .h file you want to do something like reference another class you've written, if you don't, so just on its own, if you try to pull in some random class you've written, the compiler is going to be confused because it's going to see some class that it doesn't recognize, and it's not going to know where to look. So in general, in your .h files, you're going to want to use this @class keyword. And this is something that's called a forward class declaration. And all this does is it tells the compiler that there is eventually going to be some class called foo, or whatever it is that your class you're trying to use. So the compiler doesn't know anything about foo. All it knows is that it exists, and that's all that it needs to know in order to use this header file. So on the other hand, when you actually want to use a class like foo, rather than just using @class and telling the compiler it exists, you actually want to tell the compiler a lot about it. So to do that, we're going to use our hash import, not hash include, and we're going to give it the .h file that's defining everything that the class can do. And so that way you'll get nice things like autocomplete, and the compiler will be able to tell you when you're trying to use a property or a method that class doesn't actually implement. So @interface and @class correspond, and implementation and import usually correspond. So there are two different ways of defining methods. We have what are called instance methods and class methods. So the instance method in the @interface file or the .h file are always going to be prefaced with this minus sign. And that's just going to tell the compiler that this is a method that can be called on an instance of this class. So something that you've alloced and then subsequently initted. On the other hand, a class method or a static method is something that is not going to be sent to an instance of a class, but to the class itself. So I can have something like a singleton maybe, or just some data container that rather than instantiating that object, I just want to send something to the class directly. So you won't actually have to allocate and init something. You'll just use the class name and send the message, which is the ObjectiveC term for just calling a method on the actual class. So a little less common. In general, we'll be working with these instance methods, but these do exist. So classes can have properties, which rather than methods, properties are simply variables or members of the class. So in ObjectiveC, again, there's a two-part definition to a property. So inside of the .h file, or the interface, you're going to declare the property. You're going to say, there's this property. Its type is an int, and I've called it foo. Now, inside of the parentheses here, you can give your property some attributes. So in this case, I've said that this property is non-atomic, which means that if I ever implement multi-threading, this isn't going to be safe. So in general, we don't really have to deal with that quite yet. But we just say, in general, if we don't have any threads, let's just make it non-atomic, because there's going to be some, albeit small, performance hit if we try to make these variables thread safe. We'll have things like mutexes and all this going on in the background. But if we don't really care, we can just say non-atomic. So here, after that, I've said I want to assign. So this, in general, is the attribute you're going to want to use if your properties are native data types, like int or double or float. Because we're not dealing with objects at all, much like you would say int x equals 4, you don't have to worry about mallocing or freeing it. It's just a primitive data type, so we can just say assign. If we want to use an object, in general, this will say strung, which basically does some memory management under the hood that as of this time last year, we would have cared a lot about. But because Apple's so nice to us, we no longer have to deal with that. So that's the .h file. In the .m file, we want to then synthesize the property, which is actually a really cool keyword to keep typing. So you're going to synthesize what you've declared in the .h. And what this does is it's actually going to generate getters and setters. So as we saw in our earlier lectures on good OOP design, we saw that getters and setters are generally great ideas as far as data encapsulation goes, but they're a huge pain to write, having to say get this, set this, and copy and paste a lot of code. So rather than having to do that, we can let ObjectiveC do this for us. So everywhere the compiler sees @synthesize, it's going to replace with the method a definition for getFoo and setFoo. So what this synthesize keyword also does, and this is new in Objective-C 2, is introduces a nice dot notation, which we're familiar with in Java and other languages like that, where if I say object.foo, that's the same as me calling object getFoo. So it'll actually invoke a getter, and if I want to define a getter myself, I can do that, and the dot notation is going to invoke this custom getter I've defined. So again, this was something that actually mattered a lot back in the days of iOS 4, and it was really crucial that you knew how this works. Now this is kind of like, oh, OK, I guess this is just the way we're doing it, because all the memory management is now taken care of for you. But just this kind of remains right now. So here are just some examples of ways that you can define and use methods. So here you'll notice that all of these start with the minus sign, which means that these are instance methods, or methods I'm going to call on an instance of a class. So if I have one without any arguments, I can just say its data type here. So in all cases, I'm using ID, which we remember is a little bit like void star. It's just kind of like some generic something. It's pointing somewhere in memory, but I don't really care what it is. If I want to give it a first argument, we notice that the argument is not named. So I'm just going to have a colon, the type, and then the actual variable that will represent that parameter. But as soon as I want to start jumping into multiple parameters or multiple arguments to my functions, that's when I'm going to start naming them. So in this first case, this name is not named. It's just colon name. But as soon as I want to start sending in multiple arguments, I'm going to preface them with some keyword that will effectively serve as the name of the method. And this will actually be included in the method's name. And then I can just choose some arbitrary variable that will be called. It can or cannot match the thing to the left of the colon. It certainly doesn't have to. And now to call this method, or now that we're using Objective-C to pass a message to this object, we're going to use this bracket notation, which again is the same bracket that you use for arrays in C. So the first thing inside of this bracket is going to be the object you're passing the message to. And then after that is the message name and any arguments that you want to pass in. And then one other thing, make sure that you don't forget that @ in front of NSString. It's very easy to forget, and the error message you get back can sometimes be pretty cryptic. So any questions on Objective-C syntax? OK, so if you've taken CS50 or CS61, you've probably known to love the GNU debugger, or GDB. And so luckily, because we love it so much, it's also built into XCode. And it's going to be something that's really, really handy as you start debugging these large applications with multiple classes and you're not really sure where the error is happening. This is going to be a lot more effective than trying to nslog and figure out what's going on. So all of the traditional keywords that you're used to in GDB are also here. So you can do next to jump over to go to the next line. You can step to go into a function. You can continue to the next breakpoint. And you can print out a variable's value. But what's nice about XCode is that this is actually nicely built into the UI. So here I have a very, very simple Objective-C program. Again, I'm not using the iOS simulator yet, but we will today, I promise. Just doing some simple things like creating a string, going through a loop, and calling a function. So if I want to use the debugger, the first thing I need to do is create a breakpoint. So remember, a breakpoint is just a place where we're going to pause execution. So let's just create a breakpoint right here. I can either click on the line number. You can see I have a breakpoint right there. If I want to disable it, I can just click it again, and I can enable it like that. Or if I want to get rid of it, I can drag it off, and it explodes. The keyboard shortcut for this is Command /, or the thing above the Enter key, if you don't want to be clicking the line number. So now if I click Run, you'll notice here that my execution has paused. So I can see over here, I'm at my first breakpoint. I'm just in thread 1, and if I had a complicated multi-threading application, this would be a lot more informative. So now, let's just come down here. So here's our GDB, and rather than having to type things in, we have these nice buttons. So if I want to step over the next instruction, I can just click this, and you can see now that we've advanced to here. So if I want to find out what the value of this string is, I could come down here and type something like print s, or I can actually just mouse over it, and I can see here my string's address is at that memory address, and its value is high. So all I did there is mouse over. So again, I can come down here You notice the prompt is LLDB. This is just because I've configured Xcode to be using LLVM, which is just another compiler, just like GCC. So the equivalent of GDB is just LLDB, and it behaves exactly the same. So if I type next down here, it gives me a timestamp. You can see that here I am. Again, I can look at the value of these variables just by hovering over them. So we can go through my for loop. And now down here, I have a function call. So rather than skipping over that function call, if I actually want to jump down here, I can step into the function. You can see now I've jumped down here. And again, I can actually just mouse over the variables inside of the function declaration here, and I can see what values I'm passing in. So any questions there? So definitely something that will become super helpful as you're creating your apps. So now let's actually move on to creating buttons and fun things like that. So once you open up Interface Builder, which used to be this separate program, but it's now integrated into Xcode, which is a much, much nicer experience, when you click on something, you're going to have all of these different tabs over to the right. So just a quick overview of what each of these is. So the first one, you can set options for the actual nib file, which we remember is just kind of the container for all the UI elements. You can set options regarding that file. The next one is just the documentation. So if you just want to quickly read over some button method or what you forgot what something does, the documentation is right there. And then you can just do things like customize what the view looks like, the attributes it has, and its size. And then finally, the connections, which we'll look at next. So over to the left, you'll see a few other objects. So the first, the file's owner. So this is the object that actually loaded the nib. So if remember, looking at our MVC architecture, our nib files are effectively our views, or what is displayed. So our controllers now are going to be the objects that instantiate those views. So we looked at the single view application first, and we'll be looking at that a lot today. Basically, we have a view controller, which is really just kind of a controller that's going to have a corresponding view, also called view controller. But the difference being the viewcontroller.nib is where the actual UI elements are, where you're putting the buttons and has all the information about that. And the viewcontroller.h and .m files are actually going to define what happens when you start to interact with a button. So that file's owner is going to correspond to the .h or the .m file, or basically that object that corresponds to the view that you're editing. So the first responder, we don't really need to worry about, but in general what this is the current UI view that's in focus. So if you've selected a text field, suddenly that has focus. Or if you've switched from one view to another, the current view is going to change, the focus is going to change. The app delegate, which we saw, is this kind of global class that is in charge of passing off control from a sleep or a new app to the first view controller. And finally, the window, which is just basically the topmost container for all of your views. So there are two things, two ways that we can start to interface our ObjectiveC code to the UI we create in Interface Builder. So the first is with this keyword IB_outlet. And what an outlet is that I have some object in code. So I have, let's take a button for example. So I have this instance of a UI button, which is just a class that Apple has written themselves. And that class instance actually represents a button on my UI. So I need some way of connecting the UI button in my code to the button that I've drag and dropped in Interface Builder. And with Xcode, I'm literally going to connect them. That's the technical term. So remember that this IB_outlet is actually not the type of the object, because I'm going to have a UI button object, more technically a pointer to a UI button, but it's not going to be an IB_outlet object. This is just a flag to Xcode that says that this is going to have some corresponding element in the UI view. So in my .h file, I'd want to have something like this. I'm going to create a new property, again non-atomic because we're not dealing with multi-threads, and then strong, because this is just the keyword that we're going to want to use for all of our IB_outlets. This basically says to the memory, just make sure that you don't accidentally deallocate this button. I'm going to be using this button because I've just declared it right here. So then there's the IB_outlet, and then after that is going to be the type. It's always going to be a pointer, so it's just a pointer to a button. So this is basically your workflow for using outlets. You're first going to want to define an object for each of the UI views you care about, and that's in the .h file. Then just like any other property, you're going to want to synthesize it in the .m file, or the implementation. So there's really nothing special about this property. Even though it represents an actual button on my app, there's really no different than the integer we just looked at before. And finally, we're going to connect the objects using Interface Builder. So there's your three-step process. So to actually make the connection, what you're going to do is you're going to select on the file's owner object, usually over to the left there. You're going to control-click on it, and you're going to drag your mouse over to the UI view that's represented. And then when you let go, you'll see a little list of all of the IB outlets inside of that class. You can select one and say that this object now corresponds to this view. So we'll see that in just a second. But actions are going to work in much the same way. So if an outlet represents an object, an action now is going to represent a method, or effectively a message. So when I create my actions in my when I create my methods in my interface file, rather than saying the type is a void or an int, I'm going to say the type is an IB action. So again, that doesn't mean that I'm going to be returning an IB action, because as far as Xcode is concerned, that just means void. But Xcode needs some way of knowing which methods you intend to connect inside of Interface Builder and which methods you don't really care about, else that menu would be really big. So again, the equivalent type in C is just going to be void. So the connection process is basically the same, but instead of going from file's owner to the view, you're going to go from the view to the file's owner. And then when you let go of the mouse, you're going to see a list of all the possible actions you can connect it to. So let's do that. Let's just make a really simple app. And definitely, if you have Xcode installed, feel free to follow along. So I'm going to go to a new project. Now here, we're just going to be dealing with the single view application right now. So I'm going to click this, click next, give it a name like text field example in class or something. I'm going to click next. It's going to ask me where to save it. I'll do that. OK. So here we go. So Xcode has just created my project for me. As we saw in lecture, all of these files are already written for me in a state where I can actually run the app and see something. So let's open up this nib file, which is currently blank. So now let's do a few things. Let's add a label. So over here, label is already selected. I can drag this over. So let's just put it up here. We'll increase the size a little bit. So make that here. Here. So in addition to a label, I also want to have a text field. So if I start typing in the search box down here, you can see it'll just kind of narrow it down for me, so I don't have to worry about searching. So I'll drag over a text field, and I'll make this the full width. And finally, I'll have a button. So I start typing button, spell it right. And over here, you can see I just have some button. If I double click it, I can edit the text that's inside of the button. OK, so I have three UI view objects here. I have a label, I have a text field, and a button. So the first thing I want to do is go into my .h file, so viewcontroller.h, because I just edited viewcontroller.xib. And I want to create three properties. So I'm going to say property. It's going to be non-atomic. It's going to be strong. And first thing I did was added a label. So let's just call it label. And then after that, I added a text field. So it's UITextField. Let's just call it text field. And I added a button. So let's just call it button. Make sense? Just creating these properties inside of my class that I'll eventually connect to the UI view. But these aren't just normal properties anymore. These are now things that are represented in my nib file. So what I want to do is I want to add IB outlet to all of them. IB outlet. And again, this is not the type. This is just a special flag, because we're actually dealing with UI button objects. So now, inside of my M file, in order to use these, I can get rid of this. In order to use these inside of the implementation, not outside of it, I want to synthesize them. So I have a label. I have a text field. And I have a button. So that should be pretty straightforward. There's nothing really new here. These are just standard properties. So let me just get rid of these comments since I don't need them. OK. So now inside of my nib file, I want to start connecting the properties I just created with the actual views. So I'm going to come over here to File's Owner. I'm going to hold down Control. I'm going to click, and I'm going to drag. And you can see that these outlets are starting to be selected. So I can connect that to the label, connect this to the text field, and connect this to the button. So now I can actually start referencing these things with inside of my class with something like self.button or self.textfield. So what I want to do in this very simple app is I want to take what's inside of this text field, and after the user clicks done, I want to replace the text of this label with the text inside of the text field. So to do that, I want to first define a new IB action, or some method that can be called when the user interacts with the UI view. So if I come into here to my view controller, I'm now going to say the type is an IB action, which is just a void, and I'm going to say button pressed. So this parameter here is going to be just basically some ID object, so it can be anything. But what in practice this is the element that was interacted with. So in this case, if I connect this to my button, which I'm about to do, this sender object is actually going to be the button that was pressed. So if I wanted to do something like change the button's text or remove it or something like that, I can do that by interacting with this sender object. So I've declared my method, so now I need to implement it. So I can just say void, because that's all IB action is, and button pressed. So what do I want to do? I want to take the text that's in my text field, and I want to set the text of the label to be that value. So I could just say something like self.label, and Xcode's autocomplete is really nice. So that's my label object. The text inside of it is going to be .text, and that's going to be equal to self text field text. Really simple, and that's it. So after I do that, let's say I want to do something like clear out the text of the label, or the text field. I can just now set that to be the empty string. So now I've defined my method, I've declared my method, and now I want to connect it. So before, we went from files owner to the button. Now we're going to click on the button, hold down Control, drag over here to the files owner, and we can see that we have the event button pressed. So if we click over here all the way to the right, these are all of my connections. And you'll see that I now have a new connection to the files owner. The event is touching the button, and it's going to fire the method button pressed. So if we run this app and all goes well, if I say something like hello, click done, there we go. I've changed the label, I've cleared the UI text field, and that's it. Make sense? OK. So let's talk a little bit about delegates and protocols. And these are something that's a design pattern that's a little bit unique to Objective-C. It's certainly not something that's tied to Objective-C, much like JSON is not tied to JavaScript. But it just so happens that Objective-C in all of Apple's code makes a lot of use of this particular design pattern. So the delegate design pattern basically says, if I have some object that's going to be interacted with, rather than implementing behaviors myself, like responding to a touch or responding to a swipe, rather than littering some class with all of those behaviors, I'm going to create a separate object called the delegate that's going to define what all of those behaviors do. So now in order to tell the compiler, tell the programmer what behaviors are implemented by this delegate object, we're going to use a protocol. And this protocol is effectively equivalent to a JavaScript or PHP interface. And all it is a list of methods that will be implemented by some class. So a protocol could look something like this. So I've called my protocol some protocol. And inside here, I've just listed all of the methods that are going to be implemented. So just the same syntax that we saw earlier for actually defining them in the .h file. And it's the same thing if I want to have some protocol. So one example, some protocol that Apple's written for you is called this UITextFieldDelegate. So some of the methods that are included in here are text field should return, and these names get progressively longer. But what this means is, if I implement this protocol, that means that when something happens with my text view, I can respond to various events. So for example, the one we're going to be looking at is when you press the done button. So if you ever used an iPhone, you notice that when you're entering a URL, there's a little button in the bottom right corner that is obviously not a UI view that the programmer added themselves, but it's kind of built into the keyboard. And if you want to interact with that, all you need to do is say, I am implementing the UITextFieldDelegate protocol. And because I'm implementing that protocol, that I may provide a definition of the method that will be called when that happens. So let's take a look at what that would look like. So if we open up better text field example, because it's so much better, you'll see here that in my nib, I've just removed that button because I no longer need it. I've also added some placeholder text, which is just really simple. If I go over here to the fourth tab, this just has some properties like text alignment, font size, and among them here is the placeholder. So there's actually a surprising amount that's already done for you. But now if we look at our view controller, you'll see here that I've added this to my H file inside of brackets, UITextFieldDelegate. And that means that I am implementing this protocol. So the methods that have been listed there, I'm going to provide definitions for. So it just so happens that all of the methods inside of UITextFieldDelegate are optional. So if you don't define them, then it's no big deal, because as we saw, you can just pass messages to nil, and it's no big deal. But by actually implementing this protocol, that tells ObjectiveC that we're good to go to try to use this object. So one of the methods that's defined in the UITextFieldDelegate is this method called textFieldShouldReturn. So you notice here that I don't need to do anything fancy in my .m file. So I can just provide a definition for this method. What I want to do is, again, just set the text of this label to be the same as the text that's inside of the text field. And then I'm also calling this method here, this ResignationFirst Responder. So we saw before that the first responder is going to be the UI view that is currently in focus. So if I no longer want to have a view in focus, all I need to do is call this ResignationFirst Responder method. So what that means in terms of actual UX is that the keyboard is just going to disappear, because I've effectively removed the focus from the text field. So by returning yes, I just say that, OK, it's OK to press that button. And I've also done one more thing. So if we come over to here and look at the connections, you'll see now that this outlet now exists. So this delegate, like we said, is going to be the object in which all of these behaviors are defined. So I can't simply define these behaviors inside of my UI text field, because then me as the programmer can't do anything with it. So what Apple's done is said, OK, well, if you want to respond to some system events, then give me a delegate object. So what am I using for the delegate object? Well, I'm just using ViewController, because that's what I said is implementing the protocol. So now I've connected the delegate for this object to be my ViewController class, which means that it is the ViewController class that will be passed all of those messages, including that should return. So if we look over here, something that took me a while to figure out, if you actually want to change the text of that bottom right button, you can just change this thing over here, return key. You can change this to something like emergency call, in case you're ever implementing a 911 app. And we can run this. And you can see here that as I type, the placeholder text goes away. I've changed the button, and my UI is now responding to that button press. The keyboard disappeared, and I've fired that same exact event as before. Any questions on using delegates that way? So a more complicated example of delegates is found, or not really that much more complicated, but is found in Apple's starting template code for the utility app. So if we open that up, so all I can do is I can create a new project, and rather than clicking on single view, I can click utility application. And this is just going to give me a different set of starting code that happens to look like this. So now I have not one but two nib files, because I now have two views. So this is the first view. And down here it just has a little button. And here's my second view. They've added a navigation bar up here, and they've added a done button up there. You can check that out. If you come over here to the objects, you can see this nice little hierarchy of the navigation bar, the navigation item, which is basically the container for this button, and then the actual button itself. So let's actually just walk through this code. So the app delegate is going to be exactly the same. All we're doing is we're instantiating this main view controller rather than just view controller over here. This template's called it main view controller. Instantiating that, we're telling it the nib to use, and we're just making that the first view that will be displayed in our app. So here you'll notice that they've defined an IB action for us. And they've already made the connection. This method is called showInfo. And if we jump down here to the definition of showInfo, you can see we're doing something that's very similar to what happens inside of the app delegate. So we're creating a new instance of the FlipSideViewController, which is the best name in all of Apple's templates, because you could say, I'll catch you on the flip side and all that fun stuff. So we're creating a new FlipSideViewController, which is much cooler than the main view controller. Again, the instantiation looks exactly the same. We're telling it the nib to use. We don't want to pass it any additional information. And now we're saying, all right, the delegate for this new controller is going to be me, the main view controller. So we'll look at that delegate in a bit. but now we're just saying, I want you now to appear. I want to switch from my main view controller to this second view controller that I've just instantiated. So there's nothing particularly fancy over in the flip side except for this new protocol. So this is a custom protocol that you could have very well written yourself. There's no system code here or anything. And they've called it the FlipSideViewController Delegate. That's just kind of the naming convention. End it in delegate, begin it with whatever object it's being used by. And it's just going to define one method, this FlipSideViewController did finish. So if we jump back to our main view controller, you can see that that's exactly what we're now implementing. So by providing some definition of the protocol, another class can then implement it. So you'll notice here that main view controller is actually importing the header file for the FlipSideViewController. And the reason for that being, we need to know what this protocol is. So before we can try to implement it, we need to let the compiler know that this thing exists, or else it's not going to know what protocol we're trying to implement. So we just have another IB action here that's fired when the done button is pressed. Now you'll notice that what we're doing here is we're not actually responding to the event ourselves. So when you press this done button, what's effectively going to happen is you're going to jump back to the main view controller. But you can see here that that's not what this code is doing. What we're doing is we're calling this method that we defined in the protocol. So because this main view controller has implemented the protocol, and we've said the main view controller will serve as the delegate for this class, by calling this method on the object, we're effectively allowing the main view controller, to respond to a button press in our FlipSideViewController. So to actually look at the implementation of this method, or what's going to be fired when the user presses the done button, we have to jump over here to the main view controller. And you can see, here we go. Here's our definition for the method in the protocol. And all we're doing is dismiss view controller animated, modal view controller animated. And this still is among the shorter ObjectiveC method names, which will effectively just get rid of that second view that we presented. So let's just fire up this app so you can get a sense of what's going on. So it's really boring. Now remember, the IB action is attached to this button. So when I click this button, I'm going to create a new FlipSideViewController and then change to it. Wow, that's so cool. So then it flips over, and now we're effectively on the second view controller. And again, I click this done button. Wow, that's so cool. Apple did that for you. So now if I want to change the aesthetics of this a little bit, I can actually come down here to this Modal Transition style. Let's say I don't really like that horizontal flip. I want to try something else. So without doing anything, if I just type in UI modal, you can see that I actually have all of this nice list of all the possible transition styles. So let's just pick one, like partial curl, hit enter, and I click run. Now when I click this button, we get this really cool animation that makes it look like I know what I'm doing, which is really cool despite the fact I just changed one line of code. So again, we're just switching between view controllers just by pressing the same button, and all I've done is change the transition to something else that Apple wrote for me that I think looks pretty cool. So any questions there on how protocols are used between view controllers? All right, so we'll definitely take a look at more of using multiple view controllers in your app, especially in the context of table views, which we'll see very shortly. So now let's actually build an app together. So definitely feel free to follow along, and all the code will be posted online. But we're going to build tic-tac-toe. And what this will do is integrate a lot of the concepts that we've seen so far. So let's create a new project. So we come up here to new project. Just going to be a single view application. I'll call it tic-tac-toe in class. Save it. OK. I feel like this always takes longer when the projector's plugged in. So here's our view controller. Same thing that we've seen so far. We're going to open up the nib. Nothing new here. So the first thing I want to do is get rid of this gray, because I think that's really sad. If we come over here to background, we can just change the color of the background. Now it's white. So let's do something like give our game a title. Tic-tac-toe. Sounds like a good idea. So again, if you want to center text, the best way to do it usually is to take the label, make it fill the size of the parent, which you can do by dragging and dropping. Or if you come over here to the position inspector, you can just say fill container horizontally, so rather than having to do that yourself. So we can do things like center the text. We can bump up the font size. You can go to your heart's content. You can make it bold. Wow, we're impressive. And that's it. So for our board, let's create just some grid of UI buttons. So over here, much like we did in class, we can just drag over this button. I want this to be exactly 75 by 75 pixels. So rather than trying to drag it and drop it, I'm going to come over here to the size inspector, say the width and the height are 75 by 75. And there we go. So let's make the font a little bit bigger than normally. So let's go from bold 15 to 35 or so. So there's my 35. And so now we're going to take advantage now of tags again. So remember that a tag is basically just an integer. In Android, you can actually use a whole object, but often an integer is enough to suffice. We're going to use tags to start identifying the views that have been pressed. So because I have this tic-tac-toe grid, I need a unique way of identifying each of the buttons that was pressed. So I'm just going to create tags 1 through 9. So this first one is going to have a tag of 1. Or actually, let's make it a tag of 2 since it's in the center. So now I'm just going to copy paste this button. I can Command-C, Command-V. So I have another button here, and I'll have another one over here. So there's my first row. If I want to make another row, I can just drag, highlight 3 of these, copy and paste, 1 there, 1 there, and 1 there. So now, much like we did in class, we have to annoyingly change all of these tags to match. So that's a 1, 2, 3, 4. And again, this is something that is good that we only have to do it once. But once we start looking at how to create these views programmatically, this is something that we don't really have to handle ourselves. All right, so we have 9 buttons now. So our first instinct might be to now create 9 properties and 9 UI buttons. But when we think about it, that's not really necessary. So we know that each of these buttons is going to behave exactly the same way. So that means that we can effectively use one single IB action to respond to a press to each of them. But what's handy is that, as we said before, that IB action, so if we jump back to our text field example, we remember that that IB action is passing in the second parameter sender, and that's going to be the actual UI view that was tapped. Now this is where this actually comes in handy. So based on this method alone, I can figure out what button was tapped because it's going to be passed to me. So we don't need to make a bunch of UI buttons here. We can just access them based on what is passed in using that sender property. So the first thing we need to do for our board is to create some representation. So this is back to MVC. The board is our model. This .m file is our so the board is our view. This .m file, this class, is going to be our controller. Our model is going to be a container for the data. So let's just, because we have that grid and we've assigned each of those unique number 1 through 9, that kind of naturally lends itself to simply a single one-dimensional array. So let's just create that. So let's say property non-atomic strong. So we saw in class the NSMutable Array. So let's just use that. And so let's call that our board. So we also want to keep track of whose turn it is. So that's just going to be basically an on or an off switch. So let's just make that a bool. So property, because this is now a native data type, you want to say assign instead of strong. Bool in all capital letters because it's fun to yell. And we'll call that turn. So now, immediately, we need to think of a couple actions. So the first might be what happens when the user actually taps on a button. Well, let's call that one play. So this is the action that whenever a button is pressed, I want this to be fired. So because this is an action, we can now connect each of these buttons to the play method. Again, this is probably something that once we get even better at iOS, we'll just want to do in code. So we could basically have a for loop in which every iteration of the loop, we instantiate a new button. To that button, we associate the play IB action for when it's pressed. And then we can display each button in a different location depending on where we are in the for loop to basically create this grid. So another thing we might want to add is maybe a new game button. So just drag a button here. We'll say new game. So again, we might want something to happen when we press that. So let's create another action. Just call it game, for example. And we're now going to connect, again, the button to the action simply by control clicking and dragging and selecting game. OK, so now I've declared my properties. I've connected them in IB. I still don't need this. So I need to synthesize them. They're just like any other property. So I had one called board. So let's synthesize that. I had one called turn. Let's synthesize that. All right. So this viewDidLoad method is what's going to be fired once the view has begun loading. So what do I want to do here? I kind of want to initialize all these properties that I created. So let's just start off the turn as, let's just start it off being yes, which just represents one player. 0 will represent the other player. And now something that I always forget to do is initialize all of the arrays that you've declared. So if I do not say something like NSMutable Array alloc init, and I start to try to work with this array, it's not going to work. And what's really annoying is that it's not going to throw any kind of error message or warning because it's perfectly OK to pass messages to nil. So if all of a sudden in your code you're trying to work with an NSMutable array and you're calling add object, and nothing seems to be happening, if you're like me, you probably just forgot to alloc and init it. So that's a super easy mistake to make. So now what I want to do, let's just start off our game. So we declared some method called game, and that's going to represent a new game. We don't really need to pass it any arguments, so let's just send it nil. And this is going to now initialize our game board. So let's do that. So down here, just an IB action, so we could just use the void type. So nicely autocompletes for us. So we need to do a couple things when we restart our game. We first need to wipe out our model and get that to be all set. So that's going to be affecting that board array. After we update the model, we want to update the view. So we want to make sure that each of the buttons basically isn't displaying an X or an O. And then we just want to remember to reset the turn. So it's always X always goes first, since I'm always X. So we'll just say that that's going to be set to the X switch or yes. So now we want to clear out all of the objects inside of my NSMutable array. So I'm going to say self.board. And right now you're like, I don't really remember what that method is. This is where Xcode's autocomplete is amazing. If you just type any letter and then delete it, you can see a list of everything that you can actually send to this object. So if I start typing remove, because I think it starts with remove, you can see that remove all objects is there for me, and will do just that. It will remove everything inside of that array. So now I want to actually update each of those buttons. So you remember that in this case, we certainly could have, but we did not create a button for each of those, did not create a button property for each of those buttons on our view. But what we can do is use those unique tags that we assigned to access each of the buttons. So there are 9 buttons, so we're going to need a for loop from 0 to 9. So we numbered them 1 to 9, so I goes from 1 to 9. Always happens. All right. So now we want to somehow get a button. So let's just start off by declaring a new button object. Let me zoom in a little bit. So again, it's always a pointer. So we're just going to call this one of our cells. What we can do here is say self.view. So remember that this was just the top-level UI view that was already created for us. And this earlier is what I changed the color of from gray to white. So this is just already built into my view controller. So I'm going to say view, and I can get this. So this is much like JavaScript's document.getElementById. So given some numerical tag that is a child of this view, I want to get the view with that tag. So by saying something like this, what I can actually do is iterate through all of my buttons based on their tag. Now you notice here I have a little yellow line. So let's mouse over this or click it. So incompatible pointer types, initializing UI button, whatever, with type, whatever. So why is that happening? So this view with tag, the return type is going to be a pointer to a UI view. So there's no such thing as like button with tag or text field with tag, just because that would be kind of dumb. So we know that this view with tag is returning a generic UI view. But I know that I've set up my view controller such that everything that will ever be returned here from a tag from 1 to 9 is going to be a UI button. So what I can do is simply cast this to a UI button. So the reason this works is because a UI button is a UI view. The button class descends from the view class, so I can safely say that if I know I have a view, I can easily make that a button. So I'm converting this more generic parent class into a specific child class because I know that everything here is a button. What is even helpful here is something like this. So if I wanted to determine what it was, and I don't have to in this case, but I can use this nice method isKindOfClass, then I can say something like UI button class. So we don't have to do this here. But what this does effectively is allows me to determine the type of class that was returned by a view with tag. So this would say to me that, yes, I am dealing with the UI button. So this class method here is an example of a static method. So you notice here that UI button, this is the actual class. So we're sending a message to the class, not an instance of the class. So this comparator here is just going to say yes or no if this view has this class. So in this case, we don't have to do that. But in general, as you start making these dynamic GUIs with tags, that's probably a habit you want to get yourself into. So now we just want to clear out the text inside of this button. So the method to do that is simply SetTitle. So again, autocomplete's amazing. So SetTitle here, you notice it takes 2 arguments. So the first is going to be what text will be displayed in the button. And the second is going to be the button state. So the states can be something like normal, which is what we're going to be using, so UI control state normal. Or you can see here something like when the button's disabled, if you want a different text when it's disabled, or a different text when it's being clicked and the background is changed from white to blue. So in this case, we want this to happen when the button is just in some normal state. And finally, we've just cleared out our board array, so we want to add in some value that represents a blank cell. So let's just say self-board. We want to add a new object. So you'll notice here that we need to add an object. And the type here is an ID, which is just some generic object. But ID does require that we're working with a pointer. So we can't do something here like add object 0. And in fact, we're not going to get yelled at, but we will get yelled at because we want to work with actual objects here. So rather than using just the primitive int type, what we can do is use this wrapper class called NSNumber. So NSNumber is just some generic class that represents any type of number, whether that be an int, a float, a double, a char, etc. So in this case, I want to create a new number, and I want to give it a 0. So now effectively, I have a bunch of objects that are basically just wrapping some data type, and each of them has a value of 0. Which, if I'm some good programmer, what I might want to do is something up here, create a new define statement that does something like define blank to be 0. So rather than working with zeros, I can start working with things like blank. And we're still going to be able to build. OK, so that should be everything we need to set up our game. So we set up first the model, and then down here we're setting up the view. And so our state is all reset. That make sense, everybody? OK, so now let's take care of that play method. So this is the method we want to be called every time a user taps one of those cells. So the first thing we want to do is we want to take this sender object and convert it into a button. And we know that the sender is going to be a button because we only connected this to UI buttons. So again, I can very safely do something like UI button. We're just calling it a cell. And we're just going to cast that to a button. So now we're working with a button object and not an ID object or something generic. And so now what I want to do is determine which button I've pressed. So by determine now, I mean where in my array am I going to be storing that? So I have an array right now of 9 elements, and there are currently 9 zeros. So when I make a move, I want to switch one of those zeros or one of those blanks into either an X or an O. So because I've one-indexed my tags, just because 0 is the default and it was probably taken by a lot of things, so I just started off with 1 since that's not taken. So if I want to get the tag of this button, I can just say cell.tag. Or int, so int I is cell.tag, and we're just converting from 1 index to 0 index, so just -1. So you notice here that this is just an integer. There's no object or anything fancy with the tag. So now when we make a move, the first thing we want to do is make sure that this is actually blank. So what I've done here with this index and converting the cell from a 1 index value to a 0 index value is I've given it now a position inside of my board model. So inside of my internal representation of the state, I can get the state that currently corresponds to this button state. So the only time that I want to allow the user to make a move is if the current button is blank. So if the board, and now I want to get I want to index into this array. So the method to do that we saw is just object@index. The index here is just I, because I've calculated that. The first button has a tag of 1 and an index of 0 inside of this array. So I want to now convert this NSNumber object, which again is just some wrapper for a primitive data type. I want to convert that to an int. So I'm just going to send it the int value message, which again, something like that can just be looked up in the documentation. Now if it's blank, here is where I actually want to make my move. So we have two cases. First, if it's x's turn versus y's turn. So if it's x, we're simply going to say cell, we're going to set the title to be an x so that an x will be displayed in the button. We only care about this normal button state because we're not doing anything fancy. So that's, as we saw when we cleared the board, is the way to update the view. So now we want to update the model. So right now we know at index I, the index corresponding to the button that was just tapped, we have stored a 0. So we want to change that representation to be, in this case, because it's x, let's just choose 1. So we want to change that inside of our model to go from a blank to an x. So we definitely want to do something with self.board. And there just so happens to be a method called replaceObjectAtIndex. It's going to take first an index. So again, we're just going to use I because that's the index we're working with. So now we want to take the value that was there, of that object, and change it into another object. So the second argument here is just going to be what is now being stored inside of that array. So just like before, we're going to use this wrapper class, and we're going to say number with int, and it's going to be a 1. So does that make sense? This is effectively in C, if we were just using regularly indexed arrays, we could say something like self.board equals NSNumber, whatever. So these two statements effectively are the same thing. This is just the way of expressing this statement, which is just a traditional indexing into an array. And this is just the way of expressing that when you're working with an NSMutable array or an ObjectiveC object. Some languages will actually do that for you. ObjectiveC is not among them. So that's the move for x. The move for the O is going to be very similar. So rather than setting it to be an x, we're now going to set it to be an O. And rather than setting it to be a 1, let's just choose 2 because it's something that's not 1. And finally, we want to say that it is the other person's turn. OK. Make sense to everyone what we did there? All right, so let's actually run this because we're kind of in a working state now. So if we run this, you can see here's our board. If I click a button, there's my x. So I click this button. It recognized that this sender parameter is going to be this button. I found the correct index into my model. Now if I click this one, I get an O, x. Sadly, what we cannot do yet is determine who won or when the game is over. But you can see that if I try to make another move here, it's not going to let me, which basically says that the interface between my controller and my model is working correctly. So in order to determine who's won, there might be some cool mathy way to do this, but it basically boils down to comparing some elements inside of my model. So because we're low on time, let's just pull a David and pull this one out of the oven. So you can see here that I've just defined some more methods. So first, thinking about design, I've thought about how I can decompose this large problem, is the game won, which ultimately is answered by this method won, into smaller subproblems. So the first two subproblems I came up with are, well, is there a win in any of the rows, meaning all 3 cells in the row are the same, or is there a win in any of the columns? So that's 2 new subproblems, but they both share something common in them, and that's we're comparing 3 cells. So I've decomposed the problem of columns and rows into an even smaller subproblem of comparing the value of 3 cells. So I have this method called check. This is going to be an index into my board array with 2 other indices into my board array. And I think that's all I've added. So if we come over here, you can see my play method, which is now commented and will be when it gets placed online, is going to call this. So after I've actually made the move, I'm now going to check if I've won the game. And if this won method returns true, that means that someone has won and the game is now over. So the won method looks pretty short because I've done this decomposition into smaller problems. So this says the game is won if one of the rows has won, or one of the columns has won, or, and we've just here special case the diagonals. So cells 0, 4, and 8 being the forward diagonal, and 2, 4, and 6 being the anti-diagonal. So check rows and check columns again. It's just kind of what's expected. So there are 3 rows. So I have a for loop from 0 to 3. And so I want to check the first cell in each row. So that's going to be cells 0, 3, and 6. So effectively this I times 3. And I want to compare it to the next 2 cells in that column. So we're checking cells 0, 1, and 2. So I plus 1, and I plus 2. We're doing that 3 times. So I've then checked every row. Next, we want to check every column, which is very similar. Again, there are 3 columns. But now instead of checking the cell to the right, I now want to check the cell below it. And inside of my one-dimensional array, that's just going to correspond with adding 3. So again, if any of these things are the same, return yes. And finally, my generic check method does 2 things. It first makes sure that all 3 cells are not blank. And then here we're comparing x to y, and then comparing y to z. Noticing here we're using and instead of or, because both of these things have to be true. I don't need to check x and z, thanks to the magic of the transitive property. So if these 2 things are true, that means all 3 cells must be the same. So clear on how we're checking how the game is won? So just one more side thing here. So once the game is won, you'll see here I'm calling this method. So UI alert view is the equivalent of JavaScript's alert, which is basically just this nice built-in pop-up that you've seen if you've ever received a text message or something like that on your iPhone. So we have a really big constructor here, which basically allows us to set a lot of properties inside of this pop-up, which is not so true with the JavaScript alert box, and that's why you see people implementing their own a lot. So we're allocating a new pop-up, and so we have a few things. So this title is going to be the title of the pop-up, which is the text that's displayed at the top. Some message. Here we have the delegate pattern again, so we'll take a look at that next. Every pop-up must have at least one button, and so ObjectiveC has decided to default that to the cancel button. So we have the text for our button there, and we don't want any other buttons, so we're just going to say nil. If I wanted to, I could pass in a list of strings, and it would create buttons for each of those strings. So now we're going to show the pop-up. So as was suggested here, I'm using this class as my delegate to the UI alert view. So if I jump into here, rather than UITextFieldDelegate, I'm now just implementing the UI alert view delegate protocol, which says that this view controller is going to be the delegate for the UI alert view. So that protocol, again, has a bunch of optional methods, one of them being this one here, this alert view did dismiss with button index. So this argument here basically tells me which button was pressed. In this case, I really don't care since there's only one button. So what do I want to do in this case? I want to start a new game. So once the game has been won, I'll display a little thank you and restart the game. So here in this version, I've now connected this new game button with that game method I created. So if I come over here to connections, you can see that I'm now calling this method called game, again made possible because I've set this IB action flag up here on game. But just because this is an IB action, that doesn't mean that this can only be called by some UI element, or called basically by iOS for me. I'm still free to use this method throughout my code because this IB action is just a void. So you'll see here, as we did before, inside of my view did load to start a new game, I'm just using this same IB action that's being used by when I press the new game button. So I'm using that here, and then again here, when I dismiss that pop-up, I want iOS to start a new game for me. So if we just run this app, again, the code will be posted online, and this version is much more nicely commented than the one we threw together in class today. So if I go X, 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 O, X, you can see I have a congratulatory button. you can press the I'm the best button because you are, and then it starts a new game for me. So similarly, if I start playing and it turns out that nobody won, or I can't even do that, I'm too good at tic-tac-toe. So if I click the new game button, I can again just wipe the same state, so using that same method. So you might, in your time between now and the lab, or even if you want to get some more iOS practice, run through this and try to add some new features, like detecting when the game is a draw, or displaying who actually won. So in this version, I just say you've won. Maybe you should return exactly who won the game and display a different message, or do things like keep track of how many games have been won. And you basically could make an iOS app that rather than charging 99 cents for something like this, you could charge $1.99 and make twice as much money as me. So that's it for this week's section. Hopefully this will get you started on building some starter apps before we jump into our next project. Thanks.